Have you ever wondered how your projects go from just doing things to actually being smart? You know, how they react and respond and seem to make choices all on their own? Well, today, we're going to give our code a brain. We're diving into the absolute cornerstone of decision-making in programming, the if-else statement.
So let's start with the big picture. How on earth do our little microcontrollers and circuits actually make decisions, right? How does a thermostat know when it's time to kick on the heat? Or how does a simple button press magically turn on a light? It feels complicated, but trust me, the answer is way simpler than you think. It really all boils down to one of the most powerful questions in the universe, both for us and for our code. What if? Seriously, every single complex decision your project makes is just built on a pile of these tiny, simple what-ifs questions. What if this button gets pressed? What if the temperature sensor reads about 80 degrees? What if this sensor here detects an object?
Now, in the world of programming, we've got a fancy name for these decision-making tools. We call them control structures. And that's exactly what they do. They control the flow, the direction of our code. The best way to think about them is like a fork in the road for your program's logic.
And the most famous, the most fundamental control structure of them all is the if-else statement. This is our main tool for asking that what-if question. It lets our program look at a situation, at a condition, and then choose between two totally different paths, path A or path B. This is really the heart of how our code starts to feel alive and responsive. So really picture this. Your code is just running along, executing line by line, and then, bam, it hits an if-else statement. Everything stops for a microsecond. It's arrived at that fork in the road. It can't go both ways. It has to make a choice. It looks at a condition to figure out, do I go left or do I go right? It's a simple yes or no choice, and that simplicity is what makes it so incredibly powerful. Let's break down how that decision actually happens. First, the code gets to the condition. That's the question it needs to answer. Now, if the answer to that question is true, it jumps inside the if block and runs whatever code is in there. But else, if the answer is false, it completely ignores the if block. It just skips right over it and runs the code inside the else block instead. It always picks one path and never both.
Okay, so how do we actually write these questions? How do we phrase them so our little Arduino chip can understand what we're asking? Well, it takes a special kind of grammar, a specific language of comparison that we have to learn. We build all of our conditions using these special symbols called comparison operators. These are the tools that let us compare one thing to another, like checking if a variable is equal to the number 5, or if it's greater than another number. You can think of them as the verbs in our conditional sentences.
And as you can see, they're pretty straightforward. We've got the double equals to ask, is this thing equal to that thing? We've got exclamation equals equals, which just means, is this not equal to that? And then you've got the ones you remember from math class, greater than, less than, and their cousins, greater than or equal to, and less than or equal to. These 6 little symbols are basically all you need to ask almost any question you can think of in your code. Now, before we move on, I have to pause and point out a classic rookie mistake. I mean, we have all made this mistake, trust me. It's all about the equal sign. Using one when you meant to use two or the other way around can create some seriously confusing bugs that are a real headache to find. And this slide just lays it out perfectly. A single equals sign is what we call an assignment operator. It gives a variable a value. It's a command. It says, hey, x, from now on, you are equal to 10. But a double equals sign is a comparison operator. It asks a question. It asks, hey, x, are you already equal to 10? One is a command, the other is a question. Getting that difference down is absolutely crucial. All right, that's enough theory. Let's get our hands dirty and see how this all comes together in the real world. We're going to build a super simple project, just using a button to turn an LED on and off. This is pretty much the hello world of electronics, and it's the perfect way to see our if-else statement do its thing. The hardware for this is about as simple as it gets. Our output is just an LED, and we'll hook that up to pin 6. Our input is a push button, which will connect to pin 2. And, pay attention to this part, we're going to set the button's mode to something called input pull-up. This is a really cool little trick that makes our circuit and our code way simpler. Let me show you what I mean. So, input pull-up is this awesome built-in feature. Think of it like this. It tells the Arduino to keep the input pin in a default high or on state, which the code reads as the number 1. When we physically press the button,
we complete the circuit to ground, which pulls that pin down to a low or off state, which the code reads as a 0. So it's a little backwards. For us, a button press looks like a 0. That's the magic number we're going to be looking for. Okay, so inside our main loop, the part of the code that just runs over and over and over, the very first thing we're going to do is check on the button. We'll do a quick digital read on pin 2, and we'll save its state, is it a 1 or a 0, into a little variable we'll call val. Easy enough. Now our program knows if the button is being pressed right now.
And here it is, the moment of truth, the heart of our entire program. We use our if statement to ask the big question. If val equals 0. See those double equal signs? We're asking a question. We're asking, hey, is that value we just read from the button equal to 0? Which, in plain English, just means, has the button been pressed? And this is where it all comes together beautifully. If the button has been pressed, that is, if our condition val equals 0 is true, then we run the first chunk of code. We digital write our LED pin to high, turning the light on. Else, if that condition is false, meaning the button is not pressed, we run the second chunk of code. We digital write the LED pin to low, turning the light off. On or off. It's that simple, powerful decision in action.
And that's it. Just like that, you've done it. By adding one simple if-else statement, you've given your code the power to sense its environment through an input and make a logical decision that affects an output. Your code is officially smarter now. So let's just quickly go over what we learned. The if-else statement is what gives our code its decision-making power. Those decisions are based on conditions, which are really just questions that we build with comparison operators, like the double equal sign. And this is how you connect inputs, like our button, to outputs, like our LED, to create projects that are truly interactive. It all starts with this simple, beautiful logic. So you've now mastered how to make your code choose between path A and path B. But what happens when you get to a crossroads that has 3 or 4 or even more possible paths? How do you handle situations that have more than just 2 options? Well, that's where things get really interesting, and it's exactly what we'll be exploring next time.